Okay, what's up guys? This is another episode of SDE, Solving Differential Equations. And with me is Mr. Edwin and our good friend Mr. Heartthrob Asian, Steve.
Hi.
Okay, so today we will be tackling growth and decay differential equation, and I would like to direct your attention to this problem right here. Alright. The best way to tackle this kind of problem is using a table. Alright. So in this we can see the table that was created a while back, and I would like to explain some parts here. Okay, so in this we labeled x as the x billion as the population, and the t as the time, and we labeled that as years. All right, so in 1940 that's the initial year, so that would be 0, and the initial population is 2.35 billion. And since the next is 1970, so that's after 30 years, and that would be 2.94 billion. Now we would like to find how much is the population in 1995 and 2013. And in 1995, that's after 55 years of the initial year, which is 1940, and 73 years after 1940 is 2013. Now, for the solving of K would be the job of Mr. Edwin right here. So, Mr. Edwin, come and help me here. Okay.
We'll find K.
Video na, by the way. Ay.
Okay,
nakakat ko lang naman tayo.
okay, so now that the problem has been explained by Mr. Daniel Platon, we will now find K. So the basic formula is dx over dt equals kx. Now, then you need to put together the same variables. So dx over x and k dt. Now integrate both sides and put the limits from the given table, 2.35 to 2.94 for x and 0 to 30 for k dt. Now, the integral of 1 over x is ln x, and the integral of k dt is kt. Now, just substitute the limits to the variable, and you will get ln 2.94 divided by 2.35 equals 30k. So to get k, you just divide both sides by 30, and you will get k equals ln 2.94 divided by 2.35 all over 30. Tapos iwan nyo na ng ganyan para mas madali na lang sa dulo.
Okay. Okay, Steve. All right, go.
Okay, to solve the first problem, which is the population during 1995, we will get this equation. So to solve this, let's integrate dx over x and k dt, which are the limits from 0 to 55 and 2.35 to x1. So the integral of dx over x is ln x, and the integral of k dt is kt, from 0 to 55 and 2.35 to x1. So we distribute the limits, and this is the equation now. ln of x1 over 2.35 is equal to 55k. And in order to get rid of ln, we need to raise it into e. So e raised to ln is equal to 1, and this will become the constant. So x1 over 2.35 is equal to e raised to 55k. And x1 is equal to 2.35 e raised to 55k, which is the answer a while ago, ln of 2.94 over 2.35 all over 30. And x1 is approximately 3.54 billion.
Okay, okay. Okay, hi again. So we're out to get x2. We're just going to use the same process of solving, just like the first one, but we just changed x1 to x2, and 55 to 73 right here. So this one's x1 before, x2, this one's 73, 73, 73, 73. Since obviously 73 is bigger than 55, be bigger, which is 4.05 billion.